I'm available to you guys. I hear what a lot of my classmates at the graduate level are doing is holding virtual office hours. So essentially just getting on Zoom like I am right now, and then you guys can enter the chat, so to speak, if you guys want to talk via video, or we can find a time to chat using the D2L service that they've installed. So I'll be responding to those of you that have emailed me recently. I'll be responding to you soon, and we of course can just figure it out case by case for those that need anything. But without going too far into just talking at you guys, I want to get started on trying to show you guys what's going on here with paired sample t-tests. So I'm going to go ahead and share my screen here, or attempt to share my screen with you. Let's see. Okay, here we go. Great, awesome. So let's see here. Let's just go ahead and go through this. I'm going to keep it fairly brief because this is incredibly awkward. I had to shave just for this. I was looking like a quarantine bum before today, but you guys know me. You know how it is. All right, so let's get started. So paired samples t-tests. Again, this is our third type of t-test that we've talked about. As you'll recall, we've talked about the single sample t-test where we're comparing our scores to an overall population that we don't necessarily know a lot about, but we want to see if our group of scores came from the overall population. The second one, the one that we've all talked about, this was the last time I saw you Monday people, but that was the independent samples t-test, which were used to compare two separate samples to see if they are from different populations. And finally, what we're talking about today and what you're being asked to do for the assignment is paired samples t-tests. So that's where you use one sample, but you measure the same people more than once. So if we think back to an example that we've talked about a few times in class and a few times, sorry, I looked at myself and lost my train of thought. If we think about an example of the SAT prep course, so if we think about that in terms of a single sample t-test, that would be if I had you guys take an SAT prep course and then take the SAT, and I compared your scores to the overall population mean, right, to see if you guys come from the population mean. Another way I could do it is if I had you all, I think there's about 60 or 70 of you, take the test or take the course and then take the SAT. And then I had another group of stats students, or just another group of students, and I just had them take the SAT with no prep course, and I compared you guys to each other, right? That would be two independent samples where I'm comparing you on the same measure to see if you're from the same population of test takers or if you all do better because you're part of this new population of test takers. Finally, the one we're talking about today, if we stick with this example, this would be if I gave you guys the SAT today, then we did a 4 or 5 week test course, whatever it is, a test prep course, and then I had you guys take the SAT again, and I wanted to see if there was a difference in your scores before and after the test. So just to really drive it home, remember that it's the same question, but we can ask it using just one group of students. We can ask it using two completely different groups of students, or we can ask it using the same group of students before and after the test, right? So that's what we're looking at today is this paired samples t-test. Again, Levine's test is still relevant here. The null hypothesis is that we have equal variance, and the alternative is that we do not have equal variance. Like I said, this is where we think about it kind of backwards. We want a null hypothesis. We want the null finding because we want to be able to assume equal variance. It just makes our life easier. So just kind of to get further into paired samples t-test, again, this is a repeated measure design, so keep that in mind. It's the same group of people. So if you have 50 people, you're measuring them at time 1, and you're measuring them again at time 2. There's no other people involved. It's the same subjects for use in all the treatment conditions. Some of the advantage of this is that it obviously requires fewer subjects. Even just with the example I just used, if I wanted to compare you guys to a group of non-prep course people, I would need 120 students. But if I just had you guys take the test twice, then I could easily, I could answer a really similar question with half of the students, right? It can be used to study development or change over time. A lot of the questions we ask and a lot of things that we're interested in are questions that have to do with how things change over time. So for my own research, we study how parenting and how parents' levels of stress change before and after our parent training group, right? So obviously you're using the same parents to answer that question, because a lot of what we want to know is how do the things that we do as therapists and researchers affect our clients. And this also helps with reduced problems caused by individual differences, right? So if I have you guys all take the test and then have you guys all take the test again, the nice part is that I'm comparing you to yourselves. And so you run fewer risks of there being some crazy group difference. With you guys being, there's 60 of you, and if I compared your test scores to another group, you guys may benefit from having an awesome stats teacher such as myself, and so that could cause differences. Or just the fact that when we're comparing people that are different people, there's so many things that are different. How much they enjoy school, how much they like writing, their baseline scores. When you're using the same people twice, you don't run into those kind of problems because you're the same person. There's definitely some disadvantages though. So factors other than treatment effect could influence a participant's score. For the Thursday classes, I mentioned how if we were doing something related to stress and I had a group of students that I measured in January and wanted to measure again at the semester break, if the majority of them lived in the dormitory where the bullet went through the window, that might cause higher levels of stress that I can't account for. Another example I use is when I went to the University of Alabama, there's a lot of research studies that have been going on for several years. Specifically, there was one that involved elementary school students and their levels of aggression. And about halfway through the study, a really serious tornado hit campus. And the university lost several undergraduate students, and several hundreds of millions of dollars of damage were done to the city. And so this was clearly an effect, or what we call a treatment effect, that we had to account for in our data. So now, as you might be able to guess, a super confounding, as we call it, something that like plays into your data, a super big problem with some of the data right now is that we're all going through quarantine. So any of the studies that were happening on campus, asking students about their experience on campus, are kind of screwed because we can't control as researchers the fact that pretty much the entire world is shut down right now. And then the second disadvantage, this one's a little simpler, is just that participation in the first trial could influence your participation in the second trial. So essentially it's just practice effect, right? So even if I had you guys, even if I wanted to do the SAT question with just you guys, I would still be running the risk of the fact that the second time you take the SAT, you're probably going to do a bit better because you're more used to the timing of it. You understand the structure. You're less nervous probably. So even without a prep course, you're probably going to do better the second time because that's just how the practice effect works. So just some more information here. As you can see, I clearly lost my train of thought when I switched slides. Hypotheses use different scores, right? So we have to use different scores to answer this question. So essentially we're taking your score 1 versus your score 2. And for every individual participant, we're finding the difference between their two scores rather than differences between the two groups on average. And so our null hypothesis, remember our null hypothesis is always that there's nothing going on. It's whatever the 0 is in the question, it's that. So the average difference, right? So if I take all of the scores minus their first scores, and I now have this list of different scores, the null hypothesis is that the average of those different scores is 0. The alternative hypothesis, our research hypothesis, is that there's a treatment effect that causes the scores in one treatment condition to be systematically higher or lower than the scores in the other conditions. And so essentially, remember we've talked about degrees of freedom a few times now. It's always your n minus 1. Since we only have one group, the degrees of freedom is still n minus 1 rather than how it was last week. So here's our equation. It should still look fairly similar to the majority of equations we've worked with so far. This right here is your mean difference for the sample. And then over here is your mean difference for the population, which again, as I keep trying to drive home whenever I can, in the null hypothesis, which is what we always start with, that would be 0, right? So, and this is also the standard difference that you would expect in your sample, which is calculated as such. I know from grading your test that you guys know this lingo down here, so I'm not going to be too worried about that. That's how you calculate your variance. All right, so I'm just gonna do this example real quick. This is the part that everyone should be focused on real quick here to make sure you understand what exactly to do for your assignment. And so I may mess this up here in terms of how oh yeah, I can only share a certain window at a time. Okay, let's just talk about the question real quick. 15 individuals participated in a P90X. We've got a new example topic here. 15 individuals participated in P90X, a 12-week exercise program to evaluate the effects of exercise on positive mood. Higher scores indicate greater positive affect. Okay, so the question we're essentially asking is, was the intervention effective at increasing participants' positive affect? And affect is a fancy word for mood. Anytime you see someone, for the most part, anytime you see someone talk about affect, it just means mood. If someone ever, we love using fancy words in psychology, so we'll say that someone has a flat affect, it means that they don't have a wide range of emotions. They're a pretty subdued person. Pretty much the opposite of me, being your effusive and gregarious TA. So anyways, what type of t-test? This should be pretty obvious considering the name of the lecture. You need to get a spray tan. This is paired sample t-test because it's the same people and we're evaluating their scores before and after they do P90X, okay? So let's talk again, our null and alternative hypotheses. I could ask you guys to tell me and I would get about as much response now as I do when I ask you to do this in class. But null hypothesis is that there's no difference, that the average difference of all 15 of these people is 0. And the alternative hypothesis is that there is a difference. There's our data, and here's how you do it. Okay, so I'm going to talk through it, and then I'm going to figure out how to switch my screen here. So we're going to open P90X, and we're going to do this little guy right here, which we do, quite often. Analyze, compare means, repeated measures t-test. As you see, you're using the arrow, move your time one variable over, then use the arrow, move time two variable over. So it's going to look like this, okay? So I have to stop sharing. All right, this is the actual how to do the SPSS. I kind of been having some glitches, but this is the last time I'm going to be doing it. All right, here we go. So I'm going to go to the file set here, and I'm just going to go to, as you can see, we go to analyze, compare means, paired samples t-test, and for our first one, it's positive affect score. The other one, see we got our before and after. We hit OK, and now we have our output. So here's our output. This is essentially what I just did. Remember, I did analyze, compare means, paired samples t-test. The beauty of the video is you can go back and watch me breeze through it again. So what is a t-value? This is typically where I pause and wait for you guys to answer. I'm not going to do that. You see our t-values over here. We have a t-value of negative 3.705. And how many degrees of freedom do we have? Again, if you'll recall, there were 15 participants in this, so we have 15 minus 1. And our 95% confidence interval. So I talk a lot about this in class because I think it's cool to have this kind of backup check to our significance. So our 95% confidence interval is this right here, and we have negative 1.2 to negative 4.5. And again, as I always say, what's really nice about this is that it doesn't have 0. It would be very problematic if our 95% confidence interval included 0 because 0 is our null hypothesis. So we can see that. That's a good sign. That means we have significance. We also see our p-value is super low over here. Let me get my face out of the way. As you can see over there, our p-value is very low. It's 0.002, which of course is lower than 0.05. And so we have our conclusion here of, send in the slide. So essentially what we can conclude here is that there is a significant difference in level of positive affect before and after participating in P90X. Remember, we did time 1 minus time 2, so that means that the time 2 scores were larger, meaning that we got happier. So our conclusion is that there's a significant difference between the two. The significant difference is positive, and that we have a and that we know why, right? So we're concluding that participating in P90X results in a significant positive change in mood. So that's essentially what we do for this test. I do want to go ahead and attempt to show you how to copy and paste your output. Again, not hard, but